Welcome. See, question number 66. Last class, 63, 64, 65. I by mistake, I maintained 64. Make it 65. 66. See here. There is a one block here, one block here. Connected by a member. See, some member is connecting here. Now, one thing guaranteed. See, as it comes down or it goes up, this member, one thing guaranteed, it cannot be cable. You cannot connect by a cable and hold here. That is guaranteed. So make a note here. See, for the system of blocks shown in figure, find the value of weight of block 1 for which block 2 is on the verge of moving to right. So this is a connecting member. You write the question and make a note here. This is 100% not cable. Therefore, that is, it can be a rod. It can be a rod or a member which can take compression. See, connecting member cannot be, see, you cannot put a cable here, it will fold down. So a solid member, see, when you apply load this way all, this will get compressed. Be careful. Okay. Point 2, point 3. Now, see here. What will happen is, this block is horizontally placed, 6. If this is not there, this will be sleeping here. When you put a weight here, see, this weight will try to push it that side. So they want what weight of block 1 will move the block minimum weight. See, the value of weight of block 1 for which block 2 is on the verge of moving to right side. So block 2 is on the verge of moving to right side. Therefore, see here, friction left side, and when you have a play, when due to this weight, when it is on the verge of moving to right side, this block is on the verge of coming down. See, coming down. So friction is up. See, when this moves to right side, friction left side, this will, when that moves to right side, this will try to come down. So friction is up. This is 0.2 R1, that is 0.3 R2 because of coefficient. These all statements, you know it. Let W be the weight. I don't know what is the weight. Then, very important, let C be compression force in connecting member. See, it is compression. They told angle with vertical is 50. Be careful. See, you make a note here. Be careful. I will tell you why later. Careful. Okay. Start. Unknown point of view. W is the unknown. So start from this block. Why? Unknown is here. Consider equilibrium of block 2. See here. R2, 0.3 R2, weight 6 kilonewton. Compression comes this way. That compression with the vertical makes 50 degrees. But for our calculation, see, we are considering how x-axis like this, horizontal x-axis and vertical y-y. So we want the angle with the horizontal 40 degrees. Be careful. Start. Now simple. Sigma Fy0 minus C sine, if you want to see, I written here cos sine, minus C sine 40 plus R2 minus 6 equal to 0, equation number 1. Sigma Fx0, take right side positive. You get plus C cos 40, see 40, minus 0.3 R2 equal to 0, equation number 2. Solve 1 and 2, you get C and also you get R2. R2 is not required. If you want to write R2, we get the value of C. It will come plus. It will surely come plus. Okay, over. Now, compression force came. Now consider equilibrium of block 1. See, when you take block 1 equilibrium, weight W, normal reaction R1, friction, how much it is? Oh, it is 0.2. It is not 0.3. It is 0.2 actually. By mistake, I took 0.3. See here, 0.2 R1. Okay. Sometimes it happens by mistake. Okay, I'll change it. 0.2 R1. And see, when you consider this equilibrium, this C is coming this way. See, this way. 40 degrees cos sine. Sigma Fy0, what you get? Minus W plus, see, minus W plus 0.2 R1 plus 3.140 sine 40 equal to 0. Your R1 will come, I have to calculate it now because that is wrong. That value is wrong. R1 will come 0.2 into how much? No, you won't get, you get equation number 1. Okay, you want to solve. Okay, equation number 1. Then sigma fx0 minus, see, sigma fx0 plus R1, see here, plus R1 minus 3.140 cos 40 0. Your R1 will come. It is correct actually. Okay, no problem. Your R1 will come. Okay, what to do? 3.140 into sine 40. That is 2 point not something. No, here. 3.140 into cos 40. Cos 40. R1 will come 2.405 Newton plus 2.405 kilonewton. Okay, now substitute in equation 1 where that R1 is there, substitute 2.405, you get the value of W. So 0.2 into 2.405 plus 3.140 into sine 40. Correct, 40. W will come 2.499 kilonewton. If wrong, correct it. 2.499 kilonewton. Okay, now question number 67. See, why I am doing all this question? See, I am not changing data because to save the time. You should take everything as independent question. See, now I will give the weight here. This weight equal to not very heavy weight. This is 6 kilonewton. Only, that is how much? 2 kilonewton. Okay, 2 kilonewton. Now, question is same, 100% cable. That's all same. They want to apply a force here. See, find for the system of block shown in figure. Find the least value of force P so as to move which one? Block 1 up the plane. Reverse now. Last time they want to move this block to right side. This will come down. Now as we apply force here, see, slowly that will be pushed upwards. So again, weight 2 kilonewton, weight 6 kilonewton. Why I given 2 kilonewton? Because 2.499 is the weight for that block when it's on the verge of what? Going right side. Okay, no problem. Okay, start now. Let W be weight. No, not W. So this time no let. Why no let? This time no let because already they told find the least value of P so as to move the block 1 up the plane. So no let. You can write if you want. We have to find the value of P for which this block 1 will move up. See here. C is the compression, same as last time. Now, see R1, R2. Friction, be careful. See now. Again make a note. When you apply the force P here, see, you have to apply a force P here so that this block 1 will move up. When the block 1 moves up, friction is down. This all you have to write if you want. And when that is moving up, this will go to left side. See, so this will go to left side. So friction is to right side. That's the important. This change will come. Okay. Now, once again I have to solve now. That sketch will not do. Okay, I will solve once again here. See. Now you have to consider other way. See. Be careful now. Okay. See, first, once again I will explain. See, last time they have to find this weight when this block goes to right side. So friction was left. When that is going right side, this was coming down. Friction was up last time. But this time, this force P will push this block this side. As it push this side, this block will go up. Since the question only is that way. When this block goes up, friction down. When this block goes up, This will come to left side, friction is right side. Okay, now unknown is where? See, now your unknown is here. See, P. So here, block 1, R1 and C. Block 2, P, R2 and C. Therefore, first consider equilibrium of block 2. Not block 1 now. Now you have to consider equilibrium, not block 2. Block 1. Block 1. This block. Okay, start. There is a weight here acting down of how much? Not W, how much it is? 2 kilonewton, given in the question. A weight of 2 kilonewton here. And then a normal reaction R1 here. A friction force down of 0.2 R1, 0.2 R1, and a compression force C here, compression force C here, which makes an angle of, see, now this is your XX, this is your YY. Therefore, with the XX, it makes 40-degree angle. So, this is cos, this is sine. Start. Sigma Fy0, take upward positive. Right here. What you get? Plus, our important is C now. Plus C into sine 40, C sine 40, this is 40 degrees. Okay, then minus 0.2 R1, 0.2 R1, see, plus C sine 40 minus 0.2 R1, minus 2 equal to 0, equation number 1. Sigma Fx0, take right side positive. You get minus C cos 40 minus C cos 40, then plus R1, that's all, equal to 0, equation number 2. Solving 1 and 2, our important is C. Why? With the C only you can go to next block. Your C will come, I will solve it. Mode alpha A. Unknowns are 1, unknowns are 2. Okay. Sine 40, then minus 0.2, 2. Minus cos 40, 1, 0. 4.085 kilonewton. C will come plus 4.085 kilonewton. That is the value of C. Okay, now this is completely over. I will rub this one now. I want some space. I will come this side. See, I will come somewhere here. This is not required. I will come this side now. This sketch I am not changing. Okay. Because of space problem, after that is over, don't see this one now. It is earlier. From here, next come here. Okay. Consider equilibrium of option block 1. Block 1. Okay. See. One force R1 here. Why it is R1? No, equilibrium of block 2. Oh, what is this one? Equilibrium of block 2. Block 1 already over. See, I don't know why, what is happening today. Okay, block 2. This block. Weight of 6 kilonewton. Little down I write. See, I will give exercise for you this one now. See, weight of 6 kilonewton. This block. Normal reaction R2, a force P here, and then anything else, a frictional force this side of 0.3 R2, and a compression force here. See, this arrow mark. Compression C is already known for you, 4.085 kilonewton, which makes angle with the x-axis of 40 degrees. Okay, therefore, this is cos, this is sine. This is your YY, perpendicular to plane. This is your XX, horizontal vertical. Okay, now this is exercise for you. I will tell you why. Exercise for you. See, sigma Fy0 take upward positive plus R2 minus 4.085 sin 40 equal to 0, you will get the value, minus 6 equal to 0, plus R2 minus 4.085 sin 40 plus 6 equal to 0, you get the value of R2. 4.085, mode equation mode, mode 1, 4.085, correct, into sin 40 plus 6, it is 8.626 kilo, 8 point plus 626 kilonewton. Get the answer. Sigma Fx0, exercise for you. Take right side positive. Minus P plus 0.3 R2 plus what? 4.085 cos 40 equal to 0. You get the value of unknown force P. It will come 4.085 into cos 40, that one, plus 0.3 into R2 is 8.626, 5.717 kilonewton, plus 5.717 kilonewton over. Question number 66 over, 67 over, I think, correct? Yes, 67 over. Next class, it will be 68. I will make a note here. 68. Okay, I will continue in the next class. Another 3-4 problems of this type, and then I will change over to ladder friction and wedge friction and some special type of problem, like, see, some very important question. One block placed here, another block placed here, over that one, a force applied here, maybe some tied by a cable, etc. So many examinations, they ask that one. Okay, I will all come to that later. Go through everything so far, understand everything. We will meet in the next class. Thank you.